Hello students, welcome to Helm of Science. So I hope all of you are doing well and studying hard, although the board exams has been cancelled, unfortunately due to the COVID pandemic. But still, since the joint entrance is knocking on the door, so I hope that all of you are preparing well for that exam. So in that aspect, I have taken some important questions on solid state chapter. This is a very important chapter that will carry marks in your joint entrance exam. So today we will have a discussion session regarding the PYQs of solid state. So let's get started. The first question is, an element crystallizes in FCC unit cell with a cell edge A, small a. The distance between the centers of two nearest octahedral voids in the crystal lattice is. Okay, you are given four options. You have to find here the distance between the centers of two nearest octahedral voids. Now we know that in case of FCC unit cell, the octahedral voids lie on the edge centers and body center. Okay, if you see this diagram, I have mentioned the octahedral voids on the four edges on the top face of this FCC lattice, and I have joined the two octahedral voids. So basically what you have to find, then you have to find the nearest distance between these two octahedral voids. Okay, so you are given that the edge length or the cell edge is A. Okay, is small a. Now you can see that since I have joined AC, so it forms a right angle triangle. It forms a right angle triangle ABC. Okay, and the length of AB equal to length of BC equal to how much? It will be A by 2. Why? Because the entire length is A, and if an octahedral void is present exactly at the middle point, so its length will automatically be reduced to half. So BC equal to AB equal to A by 2. Now according to Pythagoras theorem, we know hypotenuse square equal to base square plus perpendicular square. Now according to this diagram, what is the hypotenuse? It is AC. So we will write, just a minute, we will write AC square, then that is equal to AB square plus BC square. Okay, so if I solve this, AB is equal to A by 2, so A by 2 square plus A by 2 square. Okay, so this will give you A square by 4 plus A square by 4, and you will get 2A square by 4, that is A square by 2. Now this is the value of AC square. Now AC, you will get root under A square by 2, and that is equal to A by root 2. So AC, basically AC is the nearest distance between the two octahedral voids that are present in the crystal lattice according to this diagram, AC. So this answer we have to find out, and according to option C will be the correct answer. Okay, I hope you have understood this problem. Let's move on to the next one. In the next one, it says element B forms a CCP structure and A occupies half of the octahedral voids, while the oxygen atoms occupy all the tetrahedral voids. So basically you have to find the structure of the bimetallic oxide that has been formed. Okay, now first of all, I'm writing here, it is made up of three types of atoms, A, B, and oxide ions. That means oxygen is there. So in the question, it is clearly mentioned that element B forms CCP structure. Now CCP, you know, this CCP is equal to FCC lattice. Okay, we know this. So In FCC, the contribution or the Z factor, we know it is equal to 4. So we can easily write here 4. Now A, the value of A will be how much? It will be half of the octahedral voids as mentioned in the question. Now we know if the number of lattice, or you can say number of crystal structure, if it is equal to n, so number of octahedral voids will be also equal to n, and you know number of tetrahedral voids, that will be equal to how much? That will be equal to twice n, 2 into octahedral voids. This relation we know that. Oh, all right. So according to this question, A occupies half of the octahedral voids. So from here, number of octahedral voids will be also equal to 4, and A occupies half of them. So 4 into half, that means it equals 2. So my A value becomes 2, B is 4, and oxide ions, they will occupy all the tetrahedral voids. Now, what is the value of tetrahedral voids? That will be equal to 4 into 2, that is 8. Okay. So we have got the formula or the structure. So the structure of the bimetallic oxide will be equal to how much? A2B4O8. But this type of option is not given. So what you have to do, you have to reduce it. If you reduce it, you will get AB2O4. And this matches with option number B again. Okay. So B is the correct option. The structure is AB2O4. Okay. Now let's move on to the third question. The third question is, in a FCC or a face-centered cubic lattice, the atoms A are at the corner points and atom B at the face-centered positions. If atom B is missing from one of the face-centered points, then you have to find out the formula of the ionic compound. This is a question of JEE Mains 2014. Okay, the previous two was a JEE Mains 2020 and 2019 respectively. So let's get on with it. We have been told that A occupies the corner points. Okay, A occupies the corner points and B occupies the face center points. All right. Now we know contribution for corner points that we denote by the letter Z, that is equal to how much? 1 by 8 into how many corners are there? 8. So it is 1. So Z factor for A is 1. Now contribution for B, contribution for face centers, face points, or you can also write face centers, Z. That is equal to, we know for FCC lattice the number of faces is 6, but here it is 5. Why? Because in the question it has been mentioned that one of the atom B is missing from the face centered position. So the actual face points were 6 and one atom is missing, so it will be 6 minus 1, that is 5. So the Z factor for face center points is 5 by 2. So the formula of the ionic compound will be equal to how much? A value is 1, so A, B, 5 by 2. Okay, so we can arrange it in the form of A2, B5. Okay, and this matches with option D. So option D will be the correct answer. Okay, you have to be careful about this particular point, since one of the phase points are absent. So you have to note that instead of 6 it will be 5. Okay, this is a point you have to be careful about. So I hope you have understood this problem. Now come to the fourth one. So fourth one again comprised of this particular diagram. Let's just read out the question. CSCl crystallizes in body-centered cubic lattice. If small a is its edge length, then which of the following expression is correct? You are given 4 options. You have to find out which particular expression is correct. Okay, so basically this is a cesium chloride structure that crystallizes in body-centered cubic cell. Okay, and as you can see from the diagram that Cl minus are at the corner positions and Cs plus lies at the center of the body diagonal. Okay, as it is a body-centered cubic cell, so it will have a body diagonal, and the center lies Cs plus. So we know body diagonal of uh, BCC lattice is equal to how much? It is equal to root 3a, where a is our cell length. Okay. Now, if I consider r as the radius, so if you can see carefully from here, this radius will be equal to small r. Similarly, this portion will also be small r. So if you observe carefully, you can easily note that this is exactly double. So this will be equal to 2r. Okay. The radius of cesium plus will be twice that of Cl minus. Okay. So the entire body diagonal is equal to how much? Is equal to radius of Cl minus plus 2 radius of Cs plus radius of Cl minus, and that is equal to the value of body diagonal, or 2 r Cs plus 2 radius of Cl minus equal to root 3a. Okay, or you can take 2 common, so Cs plus r of Cl minus, and that is equal to root 3a. So finally the expression that you require has finally arrived. So r of Cl plus r of Cl minus, that will be equal to root 3 by 2a. And according to equation, the correct option will be C. Correct answer will be option C. Okay. So this is a bit tricky question, but not that tough. This is from in JEE Mains 2014. Okay. So this type of problems is very important, although it's a bit easy. Okay. So let's come to question number 5. So question number 5 is, a diatomic molecule X2 has a body-centered cubic structure with a cell edge length of 300 picometer. The density of the molecule is 6.17 gram per cc. The number of molecules present in 200 gram of X2 is, that means you have to find out the number of molecules that is present in 200 gram of X2. Okay, so you are given weight of X2. This is given to you. I can denote it like capital W, that is equal to 200 gram. Okay, the density rho is given as 6.17 gram per cc. Okay, the cell edge length, that is small a, is given to you as 300 picometer. So 300 picometer, if you convert this into centimeter, we'll get 300 10 to the power minus 10 centimeter, and I can also write it like this: 3 into 10 to the power minus 8 centimeter. Okay. Now, first of all, let's find out the molecular weight of this. For this, we need to at first know the formula. So we know the formula to find out the density is rho equal to Z into capital M by Na into A cube, where rho is your density, Z is the contribution factor, and since in the question it has been mentioned that it is a body-centered unit cell, so we know, I'm writing here, Z for BCC will be equal to how much? It will be equal to 2. We know this. So from here, we have to find out at first the value of M. M will be equal to rho into Na into A cube by Z. So you just have to put the values here. So rho is 6.17 gram centimeter to the power minus 3 into Na is 6 into 10 to the power 23 mole inverse into 3 into 10 to the power minus 8 cube centimeter cube divided by 2. Okay. So if you see carefully, the units that will be cancelled are centimeter cube and centimeter to the power minus 3. Okay. So if you solve this entire thing, you will get something around 50 gram per mole. Okay. So your molecular weight is 50 gram per mole. Okay. So we know the formula of this number of moles. If you are to find out the number of moles, then what we do? We generally use this formula, given weight by the molecular weight, isn't it? Okay, this is the formula. And if we are to find out, so according to this, it will be W by capital M. And here in this question, we have to find the number of molecules. So it will be equal to how much? It will be W by M into Na. That is, you have to multiply with the Avogadro number. So according to it, W was 200, okay, and divided by 50, isn't it? So into Na. So your answer will be 4 Na. And this matches with option number B. B will be the correct answer. So this is a bit long calculation, but you have to solve it patiently. Okay, don't rush, otherwise your answer will be wrong. Okay, this is question number 5. Right? You just have to know these two formulas, number of moles and number of molecules. So now we will come to our last question, that is, which of the following statements about packing fraction in solids is incorrect? So if you see in option A, the coordination number in BCC mode of packing is 8. That means in option A, the coordination number in BCC mode, BCC means body centered cubic, it is equal to 8. And we know this is absolutely correct. The coordination number in the BCC structure is always 8. Option B, coordination number in HCP mode of packing is 12. Now coordination number in HCP, and that is equal to FCC, we know, and that is also equal to 12. So this option is also correct. Mind, you have to find the incorrect statement, not the correct. Many students confuse this. Option D, let us first see option D. Void space in CCP mode of packing is 26%. So void space, you have to find the void space in CCP. CCP, HCP and FCC all are same. So void space, we know the packing fraction in FCC is 74. So how to find the percentage of void space? 100 minus 74%, that is equal to 26%. So the option, this is also correct. So the only option that is left is option C, void space in void space in HCP mode is given as 32%. This will be incorrect because I have just told that HCP, FCC and CCP all are equal, and for FCC the packing fraction value is 74%. Packing fraction is equal to 74%, and we have just solved that the amount of void space or empty space that is present in a FCC or CCP or HCP unit cell is 26. So 32 cannot be the answer. So the incorrect statement for this question is option C. Okay. So I hope all of you have understood the concepts. These are very important problems that might come in your upcoming JEE entrance exams. So I hope that you have understood all the concepts. And if you have any queries or any doubts regarding how to solve a particular question or how to approach a particular question, you're always free to ask me in the comment section. And if you have any suggestions regarding any other chapters that you like me to solve, you can always tell me in the comment section. So until we meet again in the next session, always suggest you to work hard for your upcoming exams. Try to stay safe. Do not go outside until there is extreme necessity, and keep studying and keep practicing these MCQs. Thank you so much.